All right, what is an array? It's a series of pieces of data that are arranged contiguously in memory. Now, if you took Python, you worked with lists, and we pretended that lists were arrays, but they're not really. The difference between an array and a list is that an array is fixed in length. If this phone list was allocated to be 5 items long, it's always going to be 5 items long. Whereas if you're in Python, you just call .add or .insert or something, and you can change the length. Or .delete, you can make it, squeeze down to 4 and 3, and then you can add some, right? It's dynamic. A list is a dynamic data structure that grows and shrinks upon need. The drawback of lists is that they are not contiguous in memory, meaning that when you want to get to the elements of the list, the first one might be stored in this piece of memory, the next one might be stored in this one, the next one might be stored in this one. Nowadays, computers are so fast that it doesn't really matter that lists are not contiguous in memory and that it had to bop around, in order to figure it out. Back when computers were slow, in the 70s, something, the 80s, it really mattered. These were far more efficient structures. And I suppose if you're doing some certain kind of programming, it really could matter still. But we're going to go ahead and learn about arrays rather than Java array lists, just because we got to know the fundamentals of arrays. And if you took Python, it didn't really give you a good enough introduction to arrays because they were actually lists. So it's a series of data elements that are located in contiguous memory, and each one has an address. Just like apartments, you have apartment 12, apartment 13, apartment 14. This guy's address, his index, his subscript is 0. And his subscript is 1. His subscript is 2. His subscript is 3, and his subscript is 4. Nope. Pretend I clicked in the right place. Right, like that. Those are the subscripts of those pieces of data. So if you had an array called phone list and you wanted to change one of these, you could. You could say phone list subscript 1 equals quote, or not even quote, these don't look like they're strings, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And after that line of code executed, after index 1, after subscript 1 was changed, then it would equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So this is called the index. You can also call it the subscript. When I'm typing in code, I'll say phone list subscript 0, phone list subscript 1, phone list subscript 2. And when you hear this word subscript, just know that it means square braces. And if I said phone list index 0, that would not be totally incorrect. It's easy to use the terms interchangeably. When you have an array element, you can treat it just like it was a data item of that type. So for example, come on. Come on, NetBeans. All right. So if I am correct, we are on project. What project are we on?
Lecture W, I think.
Lecture W. All righty. File, new project. Lecture W. Now I'm going to make an array of 3 integers as soon as my little blue circle goes away. Okay. So to allocate an array, you use this syntax. And if you've taken C++, it's very similar. It's just a little bit different. int, and then the square braces indicate that it's an array. And you don't have to put that space there. Most people don't. Then you give it an array name. like I'm just going to call this nums, equals new int square brace 10 in square brace semicolon. That creates a series of elements in memory. It actually allocates in memory. It goes out and grabs enough memory to hold 10 integers. And since each integer is 4 bytes long, it has set aside 40 bytes to store that data. And you can put data into each one of them. Nums subscript 0 is equal to 35. Nums subscript 1 is equal to 26. Nums subscript 2 is equal to 5 plus nums subscript 0. Int x is equal to num subscript 2 in subscript plus 1. I'm just making stuff up. Num subscript 3 is equal to x. So anywhere an integer could be used, I can use an element of the array instead, right? Normally when you use an integer, you're adding numbers together. Well, and instead of specifying an int there, I specified an array element. And since that array element is an int, it's totally legal to do that. Or here's an array element. I'm copying the value of x into it. Well, x is an int, and it's totally cool to put it inside an array element of type int. So these are just little boxes, each one holding an int. Since I only went out to 0, 1, 2, and 3, but I had space for 10, I'm going to lower this number. I'm going to make it 4. Why did I make it 4? We have 4 elements, but they start as 0. 0, 1, 2, and 3. That's 4 elements. That's the highest subscript you can use for a 4-element array, because they go from 0 to 1 less than the length of the array. Because if this was 10, you'd be able to do 0 through 9. If it was 1,000, you'd be able to go from 0 to 999. So a fancy techie way of saying it is that the index can be between 0 and n minus 1, where n is the length of the array. If the array is 4 elements long, we can access elements or subscripts 0 through 3. Anything past that will generate an exception and our program will crash. What if we wanted to print our array out? You just use a loop. In Python, you did a loop like this, and it works just as well in this language. For parentheses. Now the data stored in the array is an integer, so I'm going to do int space v, or value, colon nums. That means for every value in the array, in parentheses, print that value out. System.out.println parentheses value in parentheses semicolon. And if we run it, we'll see that the first element is 35, and the next one is 26, and whatever all the other ones are. Right? 35, 26, 40, and 41. Whatever. This is one way of printing it out. It's called a for each loop. This is a for each loop. I believe the textbook calls it that as well. Some people call it something slightly different. In the C# language, you actually use this keyword, for each. I kind of wish Java did too, but it doesn't. Or you can print it out by its index, right? Since we can access each element by its subscript, we can do that with an array. But we have to know how many elements are in the array. Well, there's 4. So I'm going to hard code it to 4, but then I'm going to fix it to be correct. So 4, parentheses, int I, short for index, equals 0, semicolon. I is less than 4, so it'll go 0, 1, 2, and 3, semicolon. I++. Now, something that people might want to do, and I strongly recommend it, is making this less than or equal to 3. Don't do this. It makes sense, right? Because we can only go 0 to 3. But it's better if this number actually represents the length. And I'll show you why in a minute. So I'm going to undo those changes. And I'm going to print out both the index number and the value. System.out.printf, parentheses, quote, nums subscript %d in subscript equals %d \n end quote I, or end quote comma I comma nums subscript I in subscript end parentheses semicolon. Now, did we have to make it that fancy? No, we could have just printed out nums subscript I, and the output would look just like it did on the for each loop. This is an index-based for loop. There are advantages and disadvantages of each. The advantage of the for each loop is, wow, that was easy to type. And this one, even if I'd shortened it to as much as possible, I could have just done this. I could have just done system dot, you don't have to type this, print ln parentheses nums subscript I in subscript, right? I could have just done that, not done that. But you can tell that it's still a little bit more complicated, right? Because we're referring to it by its index. So this index is just a little bit gnarlier. Not that bad, but it's easier to type this. And this syntax works with any kind of series of data, whether it's an array or a list or a vector or a stack, or there's all sorts of data structures that come built into Java. And this syntax works for all of them, whereas this one doesn't work for all of them. So for each is really nice because it's a clean syntax and it works with a whole bunch of different data collections. Why is this one better? Because it gives you the index. This one you don't have the index. You don't know which one is element 0, 1, 2, 3, and 4. In this one you do. That lets you change the elements in the array if you want to. This is a read-only way of accessing the array. But if you wanted to go through and you wanted to add 1 to every value of the array, you couldn't do it with a for each loop. You'd have to use an index-based for loop. Because a for each loop gives you a read-only way of accessing it. For each loop gives you a simple read-only method to access, I want to get fancy, you could call it traverse, the elements in the array. And the index-based for loop gives you a read-write way to access or traverse the elements of the array using an index value. And this is key, the fact that it's an index value, because you can set up parallel arrays where you have an array of first names, an array of last names, and the index is what links those together. And if you had an array of first names and an array of last names and you wanted to print the data out first name space last name, you could not do that with a for each loop. You'd have to do it this way. So when do you use a for loop? Use a index-based, yeah, I should have been use an index-based for loop if you need the index or need to change the data or are traversing parallel arrays. All right. So when I run it, oh, I messed up my fancy print statement. Well, I can type it in again. Hopefully you didn't delete it. Printf nums %d n equals %d backslash n, end quote, comma, nums subscript I and subscript in parentheses semicolon. All right. I think that's what I had. All right. And it blew up. Why did it blow up? Oh, can somebody tell me why it's blowing up? Is this what I gave you the first time? Is it exactly what I gave you the first time?
No, you forgot a comma I in there.
Yeah, I need an I comma in there because we have two placeholders. So, got to fill it in with two values. And there we go, right? So the first element of the nums array is 35 at index 0. The second one is 26 at subscript 1. The third one is 40 at subscript 2. And the fourth one is 41 at subscript 3. Now what was that bit I was talking about, parallel arrays? Let's make a list of first names and last names. There's but we're going to do this correctly. You see I hard-coded this 4 here? Well, what if I went in and I changed this to a different length? I'd have to remember to come down here and change it here. That's lame. So I'm going to change that 4 to nums.length, semicolon. That way, if I change the size of it, like if I make it 5, it'll still work, right? It's just that the fifth element is 0. We never stored any data in it. Unlike C++, if you declare an array in Java, it gets initialized to 0 until you put some other kind of data in it. In C++, it just gives you some kind of random garbage. So you have to go in and set it to something. So that's the correct way of doing an index-based for loop. But like I said, you can make it simpler. You can just print ln, and print num subscript I. You don't have to do that index. I just wanted to make it look nice and pretty there. Parallel arrays. String, capital S, pardon me, open square, close square, fn for first names equals curly brace, end curly brace, semicolon, but we're going to put some names in here separated by commas. So Bob, end quote, Carol, end quote, David, end quote. Now let's make some last names. This is called using an initializer list. So instead of saying I'm going to have 3 strings and I'm going to put something into element 1 and element 2 and element 3, what this tells Java is, you size it to however many elements are in the initializer list and then copy the elements in for me. So instead of having to do 4 statements, right, allocate and then copy 4 elements, a piece of data in, or 3 elements or whatever, does it in one fell swoop. String ln, that's an L, not a 1, equals, curly brace, Roberts, end quote, quote, Whitney, end quote, quote, Jones, end quote, end curly brace, semicolon. Real similar to how you did it in Python. But in Python, don't type this. You just would have done this, right? And you would have put Robert and, like stuff like that in there. Very similar. Now let's make a loop that will print out first name and last name of each person. I could add some spaces here to the columns just to make it real pretty, right? Bob Roberts, Carol Whitney, and David Jones. For, parentheses, int I equals 0, semicolon, I is less than the length of one of the arrays. Since they're both of the same length, it doesn't matter which one we use. So fn dot length, semicolon, I plus plus, close parentheses, curly brace, system.out.printf, parentheses, quote, %s, space %s, or we could just do this. Println, parentheses, fn, subscript I, in subscript, plus, double quote, space in, double quote, plus ln, subscript I, in subscript, in parentheses, semicolon. And it'll print out on line 1, Bob Roberts and Carol Whitney and David Jones. And as promised, Bob Roberts, Carol Whitney, and David Jones. So these are parallel arrays. Parallel arrays are when you have two or more lists, two or more arrays of the same length where the elements are linked by their index, by their subscript. So parallel arrays equals two or more arrays of the same length where the elements are linked by their index. So like you could have an array of month names and then an array of rainfalls for each month. Or you could have an array of days of the week and an array that calculated sales for each day of the week, and another array that had profits for those days of the week. So the array declaration, we've already seen how to do it. It's just the element type followed by the square followed by the variable name, the identifier. Now this doesn't allocate it, it just declares it. Until you have the new keyword or the initializer list, you can't actually use the array. It would crash if I tried to. You really don't have to do this because it's going to crash, but if I did this int like that, and then I tried to, say int v is equal to n subscript 0, right? Something clever like that. It won't even compile. It says n may not have been initialized. Well, sure enough, because we don't have any memory there for it. There's no elements in it. So that wouldn't work. So you can declare your variable, and then you can allocate it, or you can combine those into one statement, which is what we did, right? Just like that. Either way, you can create the reference in one line and then assign it in the next one, or you can do it like that. So provide a single statement that declares, creates, and assigns a 100-element array that stores book titles. All right. It's a string. So I put string. I should capitalize it since this is Java. Now what do I do? What's the next part of an array declaration? Do I do the variable name, or is there something before the variable name?
Brackets.
Yep, got to do that. And then I give it a variable name, and it's book titles. So why not call it book titles? And it's supposed to create the array as well as declaring it. So equals new string 100. Like that. So an array initializer is when you do a single statement that both allocates declares the array and allocates the space for it and fills it in. So like strings, square, students, equals, curly brace, and 3 names. Curly brace, 3 elements separated by commas. Default values for array elements. If you do not use an initializer, when you allocate the array, all the elements are set to 0. Or if they're floating point, set to 0.0. Or if they're Boolean, set to false, but a false is a 0. Or if they're references, like strings, set to null. So this is actually kind of important to mention. If you create an array of strings, it's really just an array of string references with nothing useful in them. What do I mean by that? String foods, food equals new capital S string. And I want this to be parallel to the other array, so I'm going to use the length of first name or last name. Nah, why not? I'm just going to make it 3. All right, now if I print that out, it's not going to print anything useful. Let's try a for each loop on it. I'm curious as to what it's going to print. For parentheses, int v colon food for every value in the food array, in parentheses, system.out.println, parentheses v. Incompatible types. Yeah, if each element of this is a string, this should have been a string as well. So it should have been for parentheses string. And then run it. Right, it printed out null. Unuseful. If you tried to access some elements for that, like if you wanted to create a list of foods, if you wanted to do this, string, I don't know what I'm going to call it, so just SS equals food subscript 0 in subscript plus food subscript 1, that's probably going to crash it. Didn't crash it. I wonder what would happen if I printed SS out. System.out.println SS. I'm surprised that worked. Okay, printed out null null. Anyways, that's not real data. It's a memory address that can hold the address of a string, but it doesn't have any strings in it. So if you wanted it to work, we'd have to copy some data in, right? So we could say food subscript 0 is equal to, pizza, end quote, semicolon. Food subscript 1 in subscript equals, quote, grapes, in subscript, semicolon. And food subscript 2 in subscript equals, whatever, soup, end quote, semicolon. Now when I print it out, we'll have some good data instead of these nulls. Right, pizza, grapes, and soup. And since I appended 2 of them together, I got pizza grapes, whatever pizza grapes are. So until assigned, array elements are set to 0 or some variation of 0, or 0.0 or false or null. Right, those are all just variations of 0. So you could ask the user for data and you could store it in an array. And then you could pass that array to a function, to a method to do stuff with it. Like if you wanted to write something that would add up all the scores, you could write a function, a method that would do that. Let's do that. Now let's do it first just as inline code rather than putting it in a method. So double space scores, whoops, I forgot my square braces. Double square brace scores equals, and let's go ahead and initialize it just because it's so easy to do. 90, 100, 95, 92, 88, 7, whatever, right? Just type some numbers in. Let's add up all those values. So we need a variable to hold the total, an accumulator, double total, initialize it to 0 so that our list can go through and add them all together. For parentheses, do we want to use a for loop or a for each loop? Linda, you pick.
Um,
And there's no wrong answer.
for loop.
All right. So int I equals 0, semicolon. I is less than the length of the array. So scores dot length, semicolon, I plus plus. Total plus equals scores subscript I in subscript. Then we could calculate the average. The average is just the total divided by the number of elements in the array, which you get by scores.length, right? So double average equals total divided by scores.length. And we can print that out if we care. Right? And I did something wrong. Everywhere else I used .length, what did I do? I did not put parentheses on it. When you're getting the length of a string, you do have to use the parentheses. When you're getting the length of an array, it's a built-in property of the array. You don't use the parentheses. So length with parentheses for strings, length with no parentheses for arrays. So the array length property just returns the length of the array. It's just like using len list in Python. And this is one of the advantages of this language over C++. The C++ does not have a way to automatically get the length of an array. It's kind of a pain. Here's their mnemonic for remembering whether you use parentheses or not. Ant C. Arrays, no parentheses. Strings, yes. Now I never remember that. Even when I know this, it's coming up on the next slide, I never remember what their mnemonic is. All right, so let's go back in. And we have an array of food, and we have an array of names and stuff. Let's do a different parallel array, like days of the week versus or students and their scores, or students and their height, students and their weight. Who cares? String names equals, and let's just fill in some names. Curly brace quote, Bob again, end quote, comma, Carol, end quote, comma, quote, Doug, end quote, in parentheses, semicolon. Now let's write a loop that asks, what is the weight of whoever? What is Bob's weight? What is Carol's weight? What is Doug's weight? So we need an array to hold those weights. And some people are picky and like to know it down to the decimal point, so let's use a double. Double, if I could type, come on. Double square brace weight equals new double subscript names dot length with no parentheses, in subscript, in square, semicolon, or I guess in subscript and in square are the same thing. So now we have an array that can hold 3 doubles, or however many names we have, right? If we go in and add a new name, it'll be 4. And we can write our loop that'll ask. But we're going to need an index, because food 0 is equal to name 0, and food 1 goes with name 1, and food 2 goes with name 2. So we can't use a for each loop. So we're going to have to use an index-based for loop. For, parentheses, int I equals 0, semicolon. I is less than the length of one of the arrays. Why not just use names.length again? I less than names.length, semicolon. I plus plus. System.out.print, parentheses, quote, or printf, what is %s apostrophe s weight, question mark, end quote, comma, and we need to print out that person's name. So after the comma, names subscript I in subscript, in parentheses, semicolon. Now we don't have a scanner. Scanner sc equals new scanner parentheses system.in in parentheses semicolon. Right. Better add my import for it. Add import for java.util.scanner. And it's giving me an option to do something. Use an enhanced for loop to iterate over the array. Now in a minute it's going to stop doing that. Okay, so NetBeans is calling it an enhanced for loop. A for each loop is an enhanced for loop. If I accepted that error, that warning, I could change it like that, right? And that looks fine. But we will not be able to store data into the weight array if we did it that way. So I'm going to undo that. And so then I'm going to say food subscript I in subscript equals scanner sc.next capital L line. And then we could print them out, right? For parentheses int I equals 0 semicolon I less than names.length semicolon I plus plus. You get real used to typing that particular syntax. System.out.printf parentheses quote. Let's pretend that no name is more than 10 characters long. So %10s space. And I guess we didn't ask whether it was in pounds or kilograms, so you get to make that up yourself. Percent. Let's say that nobody's going to weigh more than 999 pounds, so 999.9, that's 1, 2, 3, 4, 5. So %5d or 5.1d, excuse me, f, \n, end quote, comma. The first one is the name, so it needs to be names subscript I. The second placeholder is for the weight, so weight subscript I, in parentheses and semicolon. And we could put the word pounds after that %5.1 f, right? LBS or KGS if you like kilograms better, whichever. So if I run it, I'll get the chance to enter the weight of each person. What is Bob's weight? Bob weighs 100. What is Carol's weight? She weighs 80. I'm assuming we're going kilograms now. Of course, she's very small. What is Doug's weight? 95. And so Bob weighs 0.0 kilograms. So I've made a serious mistake. I asked for their weight and then I stored it in something called food. That was moronic. This line needs to be fixed. That line there needs to be weight subscript I equals sc.next double. Right, so we had to change that line. What is Bob's weight? 100, 80, 95. And there they go, right. There's our little table. Bob, Carol, and Doug. If we wanted the names to be justified, who remembers, right, excuse me, left justified. Who remembers how to get these names to line up on the left margin rather than the right?
Didn't you put a minus sign out in front?
Yep, you put % minus 10s, and that will give you left justified text. It'll be against the left margin. So 100, 80, 95. There we go. Just however you like it. Alrighty. So we've covered several topics actually. An array is a series of elements in contiguous memory, meaning they're all in a row in memory. They are all of the same type. Each element has the same type and is accessed by its subscript, parentheses index number. You can use a for each loop or an index for loop to traverse the array, but a for each loop does not give you the index and makes the array read-only. Two or more arrays of the same length where the elements are linked by their subscript, by their index, are called what? What is it called when you have two or more arrays of the same length where the elements are linked by their index number?
Or parallel?
Yep, are parallel arrays. How do you get the length of the array? To get the array length, use the dot length property. Two ways to create an array. One is with the new keyword. The other is to use an initializer. So for example, you could do int ia equals curly brace 1, 2, 3 in curly brace. That's using the initializer. Or you could do int subscript ia equals new space int subscript 3 in subscript, and then you'd have to fill those values in individually. Then fill in the data. Right. And this is an example of the initializer list. All right. No homework over this. I may give y'all one last final homework assignment on Thursday because you'll have a week and a couple of days to work on it. All right. I never asked. Did anybody get any typos that they needed? You good?
Yeah, I had one where I found
Okay.
it. So which one should I choose for the scan?
Always just choose add import for scanner.
Okay.
Yeah.